Hello everyone. In this video I am showing you my second project of DSA, which is the data visualizer in CPP language. For this, here I include the library IOStream for input and output, include the vector library for the storing elements as like a array, and algorithm also, which is one of the library. Then I insert the using namespace std by avoiding the written std double colon before the input and output. Here is the main function from which execution of program will start. Then I create the variable of name n of integer type and give the and print the sentence for the user to enter the number of elements. Number of elements means how many numbers user enter in this. So for the calculate the length, then all the element, then this number I stored in the n variable. If user enter the number less than or equals to 0, then I print the statement as no elements xd and returns the statement statement here which exits the loop. Then after that, vector int data and indices, which stores the all elements which user entered in this. For this, I run a loop which start from the index 0 and go up to the less than length of this number, and this is the I plus increment for this. All the data or numbers user enter which stored in the data at index I, which start from the 0 to less than of n. Then I create the variable name key of integer type and print the statement as enter the number to be searched. Means we give the number from users which we have to search in this above list. So then this input I give and stored in the name key. After that, I perform a linear search. For that, I create the vector int linear indices. This is the array name like this, and then I run the for loop from int from index 0 to less than length of n. Here is the I plus plus index which increase one by one, and check if the data of I means in the data at index I, if it is equals to key, then we push that index inside the linear indices. After that I print the linear search and check if the linear indices is empty. If the linear index is empty, means no any index is pushed inside the linear indices, means no any key, no any copy of key in this linear search we found. Then I print the statement as key is not found. Else, if linear indices array is not empty, then I print the key found at index, and then I print the index of that element. There is one of the possibility is that there can be the number of copies of given key in this list. So I print all the indices with the space, and here I calculate the total occurrence of that all indexes, means linear indices size. After that, on same array I perform the binary search operation. For the binary search operation, I have to the data to be sorted. So first I sort all of data, and all the sorted data in the binary. After that, I assign the left value as the 0 integer and then right as the n minus 1, which is the last index of that array. In the binary, then I create the binary indices is one of the array, and while if value of left is less than or equals to the right, then I calculate the mid, and the formula of mid is equals to left plus in bracket right minus left upon 2. This is the mid, and then check if the in data, if mid index is equals to the key, then I assign the mid to the I variable and then check if the variable I is greater than or equals to 0 and data of I is equals to key. Then I assign the value means key to the binary indices and then I reduce the index means I minus minus for search same key in the left part of that mid. After that I increase the left value I is equals to mid plus 1 and check if the I is less than n and data of I is equals to key. If the data of I is equals to key, then I push back this value in the binary indices and increments the I for searching this element in a right part of that mid means right part of that array. After all this execution, I break the statement and else if this condition is not satisfied, if mid is not equals to key, then I check if mid is less than key. If the mid is less than key, then I update the left is equals to mid plus 1 and else the data is not less than key means data is greater than key, then I update the right is equals to mid minus 1 and as the same as a linear search I print the binary search for understanding which for binary search as a statement. After that I check if the binary indices is empty or not. If the binary indices is empty, then we can say the key is not found. Else if the binary indices is not empty, then we can say that key found at the index and then print index at which index we get the same key in this list, and then we find the total occurrence by calculating the size of that index and print the total occurrence of this. Here I run the code, then I get the statement like enter number of elements, then I enter the 6 numbers because I want to because I want to create the array of 6 elements. Then I enter the 6 integers means 2, 3, 4, 4, 5 and 7. Then enter the number to search. Then I enter the 4. I want to search the 4. It gives search by the linear search key found at index 2 and 3 and total occurrence are 2. We can say in this array there is a 2 copies of 4 number. Then we sort the array. Then in binary search I found the key found at index 2 and 3 and total occurrence are 2. So this is my second project of DSA, which I create under the guidance of pre-grade team. My mentors is Sonia Malik ma'am. So thank you so much.